Dot product is typically represented with one of two expressions, and here we're going to prove that both of these expressions are equivalent using the law of cosines. First thing I'm going to do is actually rename our vectors u and v, and so here we have the vector u with components ux and uy, and same thing with v with components vx and vy, and that'll just help keep everything straight because with the law of cosines we see there's also a's and b's in there. Remember with the law of cosines that a, b, and c are the sides of a triangle, and theta is the angle between the side a and b. So how do I get a triangle out of my two vectors? I want to use the law of cosines, I better find a triangle. Well, I can take my vector u and my vector v and give them the same initial point. Then the only thing left to make a triangle here is I need to figure out what this blue vector is. And this vector starts at the end of u and ends at the end of v. You may remember that's the vector v minus u. Essentially, we're backtracking on u, so that it's a negative, and then we need to go the positive direction on v. So we get v minus u. And what I can do from there is recognize that with this triangle, I have, let's call A the side that is u, B the side that is v. So what is A? A is the magnitude of u. B is the magnitude of v, and so I can substitute throughout with the magnitudes of the appropriate vectors. And now, I know what the magnitude of a vector is. It's the sum of the square of the components square rooted, and for u and v that's very direct, and for the blue vector we just need to remember that the x component of v minus u is vx minus vu. And so it's the same formula, and I can plug all three of those in where I see them. Notice how my last term still has a magnitude u, magnitude v, cosine theta. I've left it like that just because I know where we're headed. We're headed to the top left equation, prove that that equation is true, and we see magnitude u, magnitude v, cosine theta up there, so why don't we just leave that alone? From here we can have our square roots and squares cancel out, and then we can FOIL our left-hand side. This certainly looks like a long mess, but if we look at it for a little bit, we can start to see that there's actually four terms on the left that are exactly identical to the four terms on the right. And all four of these terms on each side are going to cancel out with each other. And once we rewrite this with all the cancellations gone, we see we can very easily divide by -2, and we've proven what we've set out to prove, which is that the two expressions for the dot product are equivalent. Make sure to like and subscribe and let me know what you want to learn next.